All right, welcome back. This is guided practice number 5. It's going to be similar to the examples in the text 5 and 6. Now this one's got a cosine on the left-hand side and a sine on the right-hand side. I would like to get it in on one side both sides either cosine or both sides either sine. So one of the suggestions in the text was to square both sides of the equation. Now this is an a minus b times a minus b. So you get a squared minus 2ab plus b squared, or 1 minus 2 cosine x, and then cosine x times cosine x is a positive, negative times negative is a positive cosine squared x. So this is a minus b times a minus b, or 1 minus 2 cosine x plus cosine squared x equals square root of 3 times square root of 3 is 3, and sine x times sine x is sine squared x. And you're going to say, well, we didn't really get anywhere. Actually, we did, because we have some Pythagorean identities that you looked at in the last section, and we can replace this sine squared with to get everything in cosine. So remember, we can work on both sides of the equation. I'm going to rewrite the left-hand side, and on the right-hand side I'm going to replace sine squared with the quantity 1 minus cosine squared, and that comes from manipulating the Pythagorean identity that says sine squared plus cosine squared equals 1. So now I've got everything in cosine. I'm going to want to take it all to the probably left-hand side. So I've got 1 minus 2 cosine x plus cosine squared x equals, let's go ahead and distribute this first. Got 3 minus 3 cosine squared x. So again, everything to the left-hand side. I've got 1 minus 2 cosine x plus cosine squared x. 3 is positive on the right side, will be negative on the left. Negative cosine squared x on the right side will be positive on the left, just by taking it across the equal sign. Then I'm going to set it equal to 0. I'd like to find things, group things that look similar. I've got a constant, 2 constants, a 1 and a negative 3. And I've also got some cosine squares that we can put together. So 1 minus 3 gives us 2, minus 2 cosine x, plus, understood 1 in front of this cosine squared, gives me a total of 4 cosine squared x equals 0. Now this is in ascending order. I'm going to rewrite it in descending order. I have a 4 cosine squared x minus 2 cosine x plus 2 equals 0. And you're going to say, well, what have you got now? We've got a great trinomial square. We've got an a, 4, a b, negative 2, and a c of 2. And so I do not know if this is factorable, but I do know that the quadratic formula will work on this particular equation. So I've got an a of 4, a b of negative 2, and a c of positive 2. We're dropping the cosines. We're just looking at the coefficients. And if you remember, we've got a negative b plus or minus. I'm not singing. The square root of b squared minus the quantity 4 times a times c all over 2a. So it looks like a negative 2 plus or minus, and I've got negative 2, that quantity squared, minus 4 times positive 2. Negative 2. Some of you might have already caught that. All right. Negative 3 plus 1 is negative 2. All over 2 times 4. So I've got 2 plus or minus square root of 4, and this is negative times negative, which is going to be positive. 4 times 4 is 16, 2 16s is 32. Things are looking good. I've got a 2 plus or minus the square root of 36, which is 6 over 8, which is a 2/8 plus 6/8 and a 2/8 minus 6/8. So this is 8/8 or 1. This is a negative 4/8 or a negative 1/2. These are my algebraic answers. Then let's go to the unit circle and see where this is going to work.